Hey guys, welcome to another exciting video from our channel. Nothing like the James Webb Space Telescope has ever been sent into orbit. It may look into the very earliest stars in the cosmos, find proof of alien life, or it might actually run into trouble and lose all value. In today's video, we're going to talk about how NASA's Webb Telescope will transform our place in the universe. Before we get into it, subscribe to our channel and hit the bell icon to never miss a video from us. That said, now come, let's take a look. Many of the fundamental problems that have occupied astronomers over the last 50 years will be addressed by the James Webb Space Telescope. It is one of the most expensive engineering projects ever undertaken, costing $10 billion. But many things need to come together perfectly for it to live up to its promise, which is nothing less than to completely alter the course of the universe and the place of mankind within it. To peer back in time at the cosmos' infancy and observe the earliest stars flash on, you must first grind a mirror as huge as a house. If the mirror were the size of a continent, its surface must be so flat that there would be no hills or valleys higher than ankle height. Only a mirror so enormous and smooth can gather and concentrate the feeble light emanating from the furthest galaxies in the sky. Light that left its source long ago and consequently displaced the galaxies as they looked into the ancient past when the cosmos was young. The very darkest, furthest galaxies we would witness still in the process of being formed when strange forces conspired in the dark and the first harvests of stars began to glimmer. An exceptional mirror, however, is not nearly enough to read that early chapter in the history of the universe. To learn the nature of those first, probably enormous stars, to learn about the invisible matter whose gravity coaxed them into existence, to learn about the roles of magnetism and turbulence, and to learn how enormous black holes grew and worked their way into the centers of galaxies. The old starlight has gotten stretched after coming to us via the expanding fabric of space for so many billions of years, which is why no one has ever seen the period of galaxy creation. Ultraviolet and visible light blasted by the furthest stars in the sky stretched to roughly 20 times longer wavelengths on the voyage here, generating infrared radiation. The heat that emanates from our bodies, the atmosphere, and the earth under our feet is infrared light, the atom-jiggling light type that we refer to as heat. Unfortunately, these nearby heat sources overwhelm the meager fires of ancient stars. The telescope, with its large, flawless mirror, has to be very cold in order to see those stars. It needs to be sent into orbit. The problem is that any rocket fairing cannot accommodate a mirror the size of a house. Therefore, the mirror must be able to fold. A mirror can only fold if it's segmented, or if it's made of a honeycomb-like arrangement of mirror segments rather than a single unbroken surface. However, the mirror segments must be almost perfectly aligned after autonomously unfolding in space for them to collectively produce crisp pictures. To get a decent focus, one needs very accurate motors that can move each mirror segment by half the width of a virus increment until they're all in the same location. It would also reveal other possibly equally important aspects of the cosmos, such as the characteristics of Earth-sized planets orbiting other stars and the hotly contested rate at which space is expanding. The ability to see faint infrared sources would give you access to the universe's formative chapter, roughly the period from 50 million to 500 million years after the Big Bang. Beyond a perfect mirror that automatically unfolds and focuses after being launched into the sky, the telescope still needs one more component to function. Even in space, the Earth, Moon, and Sun still heat the telescope excessively, preventing it from seeing the faint flicker of the universe's most distant objects. Unless the telescope is pointed in the direction of LAGRANGE point 2, a location that's 4 times further from Earth than the Moon. There, the Sun, Moon, and Earth are all pointed in the same direction, allowing the telescope to block out all 3 objects simultaneously by building a sunshield the size of a tennis court. This kind of shading allows the telescope to ultimately descend into a profound cold and discern the weak heat of the cosmic dawn. And with that, we have come to an end of our video. If you enjoyed this video, do like, share, subscribe to our channel for more such exciting content. See you in the next video.